Hey guys, welcome to another video by Supernal Tutorials. In this video we'll be looking at Euclidean geometry. So for this question, the information given is that on this diagram, right, O is the center and BC is equals to AC, which is equals to 15 units. So yeah, BC, this is 15, and AC as well, it's 15, right? And we also told that OB is 10 units. If you look at this, you'll notice that OB is actually the radius, right? So this is actually 10 units, and OC is also a line going from the circumference to the center. So this is also going to be our radius. So OC is 10 units as well, right? Okay, so for our first question, we asked to calculate the size of x, right? When dealing with Euclidean geometry questions, it's always good to actually look at the diagram and actually check all the information you can actually extract from the diagram, right? Okay, so we're not actually gonna use all the information at one go, but it's good to actually analyze first and understand the question clearly. And I also suggest that you maybe write down all your theorems on a piece of paper and actually have them close by, because it's good to practice with possible answers right in front of your eyes. Then you'll be able to answer most questions and gain confidence as you go, right? Okay, so let's focus on our question. So we asked to calculate the size of x, right? Okay, as you can notice, x is the angle BOC, right? It's this angle right here. So looking at this right here, right, we'll notice that, okay, we asked to calculate an angle, right? Firstly, sometimes I know the challenge is to actually figure out what steps you're going to take to actually solve the question, right? So you should actually have all the information drawn out and actually try to think of a possible solution, right? From looking at this diagram, okay, we have units, right, for two lengths, right? And also we asked to calculate an angle, right? So if you think about it, cases whereby we actually have lengths and angles, that kind of relates to those rules, cosine rule, sine rule, yeah, and those trig ratios, right? But in this case, we have two sides and we're supposed to calculate an angle, right? We actually have three sides, lengths of three sides, which is OB, OC, and BC. So yeah, and we're actually supposed to calculate the angle x, right? So we got three sides and we asked to calculate an angle. So that spells cosine rule, right? Yeah. So based on the cosine rule, this is gonna be okay. This angle, right, it's opposite to what BC. So if you really know how to use your cosine rule, right, you focus BC, or rather the first term on our equation for the cosine rule will be the length which is opposite the angle that we're trying to calculate, right? Okay, so we're gonna say BC squared is equals to OC squared. No, I mean BO squared, and also plus this one, CO squared, right? Minus 2 cos x I'm not really gonna explain much about the cosine rule, but I'll actually make another video to assist those who actually don't understand the cosine rule. Okay, but for those that actually understand the rule, this is how we're gonna apply it in this question, right? So BC squared is 15 squared, right, equals to BO squared. That's gonna be 10 squared plus CO, right? We had actually figured out that OC, it's gonna be 10 units, since it's a radius as well, although it was not part of the our given information, but this is the kind of information that we can extract from the diagram. All right, BO, that's 10, CO, that's 10 again, right? And then cos x. So based on this equation, you can actually tell that we have what? We have one unknown, right? Yeah. So if you actually take out your calculator, you will see that 15 squared, that's 225, right? And then here we got what? 10 squared plus 10 squared, that's actually 100 plus 100, so that's 200, right? So we're going to take it to the other side. That's going to be minus 200. And then right here we have minus 10 times 10, that's 100, so times 2, that's minus 200 cos x, right? Then we're going to solve for this. This is going to be negative, no, it's actually positive 25 is equals to minus 200 cos x. So from here it's actually simple. Let me put that in a calculator. And then when you put this in your calculator, it will give you 97.18 degrees. So this is the value of the angle BOX, which is what BOC, which is the size of x. And in this way, you've actually solved your first question. So for our second question, we actually asked to calculate the size of ACB, right? Sometimes most people struggle with understanding the actual question that is being asked, and sometimes it is because of these different notations used to ask questions, right? Okay, let me try and explain this notation, what it actually means, right? Since you know that an angle is formed between two lines, right? Two lines radiating from a single point, right? So if you actually look at this, right, they're saying that calculate the angle what? ACB. So it is this angle right here, formed by these two lines. The two lines being what? CB and CA. So this notation says ACB. So the angle is C, formed by these two lines. So yeah, that's what this notation actually means. So okay, like over time, what I've noticed with the way metric questions are actually asked, actually not just metrics, but the way that NSC system works, the questions are actually related. So as you go to the next question, the previous answer somehow helps you to answer the next question. So on the previous question, we were asked to calculate x, which is this angle right here. X was 97.18 degrees. That's the angle right here. And this angle right here is at the center. So based on your knowledge of circle geometry, right, you'll remember that theorem that says angles at the center is twice angle at the circumference. So this angle right here at the center is twice the angle right there at the circumference. So that means the angle at the circumference is half of what we have at the center. So that means that we can actually determine that angle right there. So that's that angle right there. We could call it A, right, or BAC, yeah. But you need to understand that this notation helps a lot. For example, in the case of the angle C, right, there are many ways of actually, you can't just say the angle right here is C, because like there are two parts of this angle. The angle right here can either be formed by OCA or rather BCA. So that's why this notation is very helpful, because like an angle can sometimes be formed by two components, right? Like for example in the case of C. So yeah, that's why this notation is very important, right? Yeah. Okay, yeah, back to the question. Right, I said that the previous question actually helps you to answer the next question. So x is 97.18, right? The angle at the center is twice angle at the circumference. That means that the angle at the circumference is half of what we have at the center. So B A C, that angle right there, it's going to be half of x, this angle right there at the circumference. So this is going to be half of 97.18. I believe when you put this in the calculator, it gives you that's 48.59 degrees. Okay, so right now we have this angle right here. You need to always understand that all the information given on a question to some extent should be used, because it is not just given, it's actually helpful. So what we also know about this question is that BC and CA are equal. So this actually forms an isosceles triangle, right? From that other theorem, you'll know that the base, no, it's actually what opposite sides, opposite angles, right? So that means that those base angles right there of this isosceles triangle, they're actually equal. So angle BAC, right, is equal to CBA, right? So those base angles, this angle right here and that angle, they're actually equal. So this one is also 48.59 degrees, right? Okay, so we're looking for this angle, right? I just noticed that I actually haven't been writing the reasons for my answers. So yeah, it's gonna be opposite sides, opposite angles. Okay, so yeah, actually, but if you were listening very well, you'll notice that I actually mentioned all the reasons, so you can actually pause the video and actually write them on your own. Yeah, so okay, based on this triangle right now, we have based on the bigger triangle BAC, we have two known angles. So yeah, we can use the fact that the sum of the angles in a triangle, they add up to 180, right? So that's ACB angles in a triangle, right? So this is and this is 48.59 plus 48.59, right? So adding these two angles gives us 97.18. So yeah, subtracting 97.18 from 180 gives us 82.82 degrees. So yeah, that's our size of ACB. For our third question, we asked to calculate the area of triangle ABC. So that's ABC, the bigger triangle, right? When dealing with such questions, whereby we have lengths of sides and also angles, I suggest the area rule. Okay, for this one, I can actually explain this rule because it's quite easy, very easy, so it wouldn't need a separate video, right? When using the area rule, right, call it A, B, C, okay, and then call these are gonna be what our angles, right? And then call the sides, right? Small a, small b, small c, right? Okay, put it like this, right? To calculate the area, say we have for all the cases, right, we need to have the angle right here, a, and then the length of two sides radiating from that same angle. So those two sides should actually form that angle right there. So the rule goes like this: area of ABC, right? It's gonna be equals to what? Half, right? Half A times C times sine big A, right? So it's, we need an angle, right? And then also the lengths of two sides which actually form that particular angle. If we were focusing on C, we would need an angle right here at C, and also the length of these two sides which form angle C, right? Yeah, I hope that makes sense. Otherwise, let's go back to the question right here, right? Okay, I hope the area rule actually made sense. Yeah, that's the area rule, guys. Area rule. Yeah. Okay, now going back to our question, right? As I've mentioned, right, the previous questions always help to get the answer for the next question, right? So based on all the questions we've done so far, we've actually the new information we've actually found is this angle right here. We have the angle BAC, right? Based on the area rule, you need to have one angle and then the length of two sides. Yeah, and this case actually matches the area rule. So we have the length of this angle BCA, which is answer for the previous question, right? And we also have these lengths right here. Yeah, so the area, our answer is gonna be half of what? BC times AC sine BCA. Yeah, so if you've understood my explanation for the area rule, you'll see that this is actually correct. Half BC, that's 15, times AC, that's 15, sine BCA, that's 82.82 degrees. If you put this in your calculator, that gives us 111.62 units squared. Sometimes they say, usually they say square units, but yeah, that's all for this question. Thank you for watching this video. Please comment and also share with your friends that are actually in metric and might find this helpful. Thank you.